Hello, everyone, and welcome to the Printed Circuit podcast. You might be expecting to hear Steph Chavez's voice today, but we're recording this during the week. Steph is actually attending PCB West. So I'll be your guest host for this episode. My name is Matthew Walsh, and I'm excited to bring to you a fascinating discussion that's incredibly relevant to anyone involved in electronics and PCB design. We have a great show planned for you. I've invited Adam Kabler, our Chief Cloud Architect at Siemens Electronic Board Systems, to join me. In today's episode, we'll be diving into how cloud technologies, specifically those enabled by AWS, are transforming how we approach electronics and PCB design. We'll explore our journey of integrating cloud capabilities into our tools, the challenges we've overcome, and exciting cloud-enabled capabilities that are enhancing collaboration, security, and performance for design teams worldwide. So whether you're an engineer looking to streamline your workflow, you could be an IT professional interested in the latest in cloud security, or maybe you're just curious how the cloud is transforming the electronics industry, this episode is going to be packed with insights you won't want to miss. So sit back, relax, and join us as we explore the future of PCB design in the age of the cloud, but AWS cloud. So let's get started. Hi, Adam. I think this is your first time we've had you on the Printed Circuit podcast. Can you tell our audience a bit about yourself?
So I've spent about the last 23 years or so working in EDA software development. I actually helped develop some of our earliest cloud products back when the state of the technology paled in comparison to what we have today. These days, I manage our cloud architecture team working on the next generation of applications.
That's awesome. And so therefore, you are indeed the perfect person for this podcast, Adam. So to kick things off, can you tell us about the journey of Siemens Electronic Board Systems in bringing cloud-connected PCB design tools to the market? In other words, what drove the need for introducing AWS-enabled solutions?
There were several factors. I think one of the biggest driving forces was the need for increased collaboration. We wanted to give our customers the same level of cloud-accelerated development that the software world saw with the advent of things like GitHub. In EBS, we have a wealth of experience with providing enterprise collaboration on-prem, so we were able to leverage that experience to see how we could offer even more capabilities through the power of AWS.
That's really interesting, Adam. Can you dive maybe a little bit deeper into some of the specific capabilities that AWS has enabled in our PCB design tools? For instance, how has a capability like advanced ECAD visualization enhanced the design experience for our customers? And maybe I'm hoping there is some benefit from an IT management perspective to these cloud-enabled features.
Yeah, that's a really great question. Visualization is a good example of where cloud resources can make for a great user experience. With cloud computing from AWS, we can parallelize compute-intensive operations that would be almost impossible to do on your local computer or even on a local network. So pre-processing a multi-layer complex PCB for visualization and markup can take forever while on a desktop computer, and it would completely consume all its resources in the process. Moving this to the cloud allows it to happen much faster and with little impact to the local machine.
And so what about the benefits, though, from an IT perspective?
From an IT perspective, there are actually benefits both to IT staff and to users. So from an IT staff perspective, there's a lot of overhead for a user opening a ticket and requesting software installation and kind of going through that whole cycle. It can be very expensive. So in this case, that can be completely eliminated. So as soon as the users buy the software, they get access to it. Not only that version, but any updates that we roll out, they get access with no more IT involvement.
Clearly, that's a significant improvement, Adam. Eliminating the need for software installations and streamlining updates must save a lot of time and headaches for both IT teams and engineers. And it really empowers users to get up and running quickly and stay current with the latest features. And so with those efficiencies in place, I'm curious about the impact on teamwork. The ability to collaborate is certainly a key focus for design teams, especially with global OEMs post-pandemic. How has the introduction of cloud-based collaboration in our tools changed the way that teams work together across regions?
There are a few techniques that we leverage in our AWS-enabled tenants. Things like data replication, intelligent content caching can make collaboration seamless. So a user in one part of the world can complete a design revision and check it in, and it's instantly available securely to anyone else on their team anywhere in the world, just in the same way that software engineers can share source code. And then without even downloading any files, collaborators can review the revisions in detail with that visualization component that I talked about earlier, and then provide feedback through markup all in a web browser. Another thing that I mentioned earlier is about the visualization pre-processing. This is another case where we can take advantage of economies of scale. So once the design version is pre-processed for visualization once, everyone gets access to it without a delay.
That's really impressive, Adam. It's amazing how the cloud is enabling such seamless collaboration. And the fact that team members can instantly now access and review design revisions from anywhere in the world without even downloading files is a real game changer. I actually like to kind of switch things up and talk a little bit about security. When our customers design a product, they want to protect their design data, clearly. How does Siemens Electronic Board Systems ensure security and compliance with AWS while still keeping the tools easy to use for engineers?
That's an area that gets a lot of attention at Siemens. Our development teams go through a pretty rigorous compliance process to make sure that we're doing secure development and delivery. So we go through things like ISO 27001 and SOC 2 compliance. We regularly perform threat and risk analysis with our product security team to make sure that we aren't missing anything. And we also have an amazing team of security professionals at Siemens that help us secure our AWS accounts. They help provide the correct guardrails, access controls, vulnerability assessments, intrusion detection, just to name maybe more than a few. One more thing to mention is that we also follow the AWS well-architected framework to make sure that we're following industry standard best practices.
I totally understand, and certainly that speaks to the application, but what about the user data, which may also contain sensitive IP?
Yeah, we take customers' data security very seriously. All data is encrypted, both at rest and in flight, and secured with role-based access control to make sure that only the users with the right privilege can get to the information. So, for example, when given someone access to a design project, a user first has to set their role. So these can be things like administrator, editor, viewer. This role-based access control helps make sure that design integrity and security by only allowing changes by approved users, but still allowing other viewers to view.
I really like what you're saying because definitely security is such a key issue. And one of the other questions, though, that our customers raise when we mention the cloud to them is the performance of cloud-connected tools. How have we optimized the performance of our tools in the cloud to handle complex simulations and large data sets?
Earlier in our discussion, I was talking about the nature of advanced ECAD visualization on a complex PCB. Simulation is similar, and that is very compute intensive, but it also benefits in different ways. So there are simulation techniques you may have heard of called Monte Carlo or parametric sweep that would take ages to execute locally. So we can dynamically scale cloud resources almost infinitely to get these results much faster.
That's awesome. And here it was. I thought Monte Carlo was just about fast cars and casinos. It turns out it's also where our simulations hit the jackpot in the cloud. So that is very cool.
Yeah, totally.
It's incredible how cloud scalability is accelerating complex simulations and making such a tangible difference for engineers. Maybe switching to real world impacts, can you share a success story where a customer used our AWS tools or AWS enabled tools to overcome a design challenge or improve their time to market?
Recently, we've received a lot of positive feedback about our supply chain product and how it's helping to spot cost and availability problems early in the design cycle, which not only improves time to market, but also reduces overall cost. We recently released a video with one of our customers called Nextbase, which is a very successful company in the UK that make dash cams. So they used our PADS professional tools with our AWS-enabled Connect cloud application to collaborate with their component suppliers. I don't remember the exact number, but what I do remember, it was a lot with respect to percent improvement in their time to market.
I actually saw the video as well. I mean, Nextbase, I think, is a perfect example of a customer that's definitely seen the value in cloud connected tools and has definitely dialed in the use of PaaS Professional with Connect. So, looking ahead, Adam, what are you most excited about when it comes to integrating cloud technologies into PCB design? Are there any future capabilities or features you want to give a sneak peek to?
I think it's safe to say that our dev teams have been extremely busy, and I don't see this changing anytime soon. One of the areas that we're most excited about is in the space of design intelligence. We have some capabilities in the works that will greatly expand our customers' view of the components in their design in an easy to use format.
That's awesome. What else, though? Give us a little bit more, Ed.
We've also been working to improve cohesiveness with our desktop tools so that we can provide real-time cloud-connected data right in the native cockpit. These techniques also let us provide updates on a much more frequent cadence.
All right, it sounds like you're not going to give away the family secrets, and that's okay. Well, wait, I thought I could maybe pry it out of you, but that's okay. So I know what you mean about our development team certainly being super busy. I get to sit in on all the cloud sprint reviews. So I recognize there's a lot going on for sure. But I'm curious, though, how we are leveraging emerging technologies like artificial intelligence and machine learning in our PCB design tools. What impact do you see AI ML having on the future of PCB design?
Yeah, I can say a little bit about that. So I think AI is going to provide a big increase in design productivity as an assistive technology. So we've already added a whole bunch of features in the latest Expedition release that make the user experience even better. The key is providing the right contextual information at the right time. And AI can also help with things like predictive analysis and error detection, but stay tuned on that topic.
And I have to come back to one thing. You mentioned earlier about our rigorous compliance processes and security measures. How has collaborating with AWS in utilizing their well-architected framework influenced our approach to building and maintaining secure and efficient cloud applications?
That's a good question. So the well-architected framework provides a set of guidelines and best practices that really help us take the unknowns out of cloud development. So there are 6 pillars, and I won't go into all of them, but there's things like reliability, which makes sure that our apps are always up and fault tolerant. Security, which covers topics like data access management that we talked about and intrusion detection. There's even a pillar for performance, which is about making sure that we're providing the best user experience that we can.
I'm glad we're taking full advantage of it. I don't know as much about the well-architected framework, but I know it's in the right hands with you and the development teams. So finally, Adam, what advice would you give to other companies? I know this is asking a lot here, but what advice would you give to other companies in the electronics industry that are considering integrating cloud technologies into their products and services?
My advice would be to start by looking at the specific needs of the user base, what sort of pain points that they have, try to see where cloud technologies can address those. It's really important to have an understanding about the value that the cloud integration will bring. So collaborate closely and talk to AWS. They've been a huge resource for us. Leverage their expertise. Definitely use the well-architected framework. Also, building on secure, scalable, and user-friendly solutions. Don't be afraid to adopt modern design patterns like microservices and event-driven architectures, which can enhance flexibility and performance. Also, you can't skimp on security and compliance. These are really important to start from the very beginning. You don't want to do all of your development and save those things for the end. It's an absolute killer.
All right, so those are some excellent insights, Adam. I'm sure our listeners will find them incredibly valuable. So thank you for sharing your expertise. I'm really glad that you decided to take time out of your busy schedule to join us on the podcast. And it's really exciting, actually, quite frankly, to hear how cloud technologies, especially our collaboration with AWS, are transforming modern PCB design and providing real tangible benefits to our customers. So thank you so much for sharing your expertise and giving us a peek into the future of electronics, although I wanted to maybe kind of pull out a few more things, but that's okay. So to our listeners, we hope you've enjoyed this episode as much as we have. If you're as intrigued as I am about the possibilities of cloud-enabled PCB design and want to learn more, be sure to check out our other resources and stay tuned for upcoming episodes. Remember, the Printed Circuit Podcast is your go-to source for the latest trends, challenges, and opportunities in the printed circuit engineering industry. If you have any questions or topics you'd like us to cover, feel free to reach out. We love hearing from you. Again, one last thank you for joining us today. Don't forget to share this podcast with your colleagues. Until next time, this is Matthew Walsh signing off. I like to say stay innovative and keep pushing the boundaries of what's possible in electronics design. Cheers.